So hey guys, welcome back to the channel. This is your physics buddy and today we are going to discuss about projectile motion. This is an important topic. We are going to discuss the same with real life example. So make sure you note down each and everything. In order to excel in these particular type of questions, you have to write and solve. We are going to discuss all the main concepts related to time of flight, maximum height and horizontal range. So make sure you write and solve along with me. Let's get started.
So what exactly happens in projectile motion is we're going to talk about that. So that is the thing which came under motion in two dimensions. This is also known as motion in plane because we are going to deal with motion under two axes now. Let me give an example. Suppose you and your friend are standing in a straight line and you both are playing with the ball in such a way that you throw the ball to your friend. Similarly, your friend does the same. So if you look at the motion of the ball, that is an interesting one because here the ball is moving along the plane, not a particular axis. So if I consider that both of you are standing along x-axis, but here the ball is also traveling along y-axis at the same time. Like for example, in the first half of the journey for the ball, it is traveling in x-axis as well as y-axis in such a way that it is going forward, it is going upward. Similarly, in the next half of the journey, it is still going forward, but now it is going downward. So as you can see that the ball is moving simultaneously in both the axes. That is something we call the motion in two dimensions or motion in plane. This type of motion is also called projectile motion. Why we call it projectile motion? Because the object which we are studying, or you can say the object which is moving along x and y axis simultaneously, is something we call projectile. Whenever an object is thrown vertically upward with certain velocity at certain angle from the horizontal or from the ground, that object is called projectile. So that the study of that projectile is something we call projectile motion. So let us just define it. So basically, the name given to the object which is thrown at certain angle with certain velocity along the horizontal is called projectile.
Mhm.
So projectile is basically the name which is given to the object which is being thrown. And study of that projectile is called projectile motion. Now the most interesting part here is to understand that how velocity is changing. So here I can assume that I have thrown a projectile and it reaches like that. So during the motion of the projectile, if we talk about its velocity, so let us consider that the projectile has been thrown with some initial velocity Vi at a certain angle theta.
Mhm.
So this Vi must have two components. The one component is along x-axis, which is sometimes we call Vix. Similarly, it must have one component along y-axis. We call it Viy. These two components of velocities are something which we have already found in vectors. Well, when we were talking about vectors, when we're talking about addition of vectors, we already know how this Vix and Viy can be found out. Let me just give you a little idea about this. So just try to remember if this is V and we have to find Vx and Vy. So this Vx is nothing but V cos theta. Similarly, Vy is nothing but V sin theta. Remember?
Mhm.
So this Vy and Vx are the individual components of velocity which will carry the motion in x and y axis respectively. And these components are called rectangular component. We already talked about it. Rectangular component of velocity along x and y axis. respectively. Now let us try to understand how the component will change. If you just observe the motion of the projectile, what interesting thing here that we always look is that the gravity. That the acceleration due to gravity is always acting in the downward direction, and there is no acceleration along x-axis. Like for example, uh, if you just pick an object and just drop it from a certain point. So what is the tendency of the object to move? Like in which direction it is actually going to move? It is going to move along y-axis or in the vertical direction. Why? Because the acceleration is always there in vertical direction. You will never see that you have just dropped an object from certain point and it moves along x-axis in whichever direction possible. We never see this. Why? Because there is no acceleration lies in x-axis. But in y-axis, there is always an acceleration called acceleration due to gravity. So due to which, if I talk about these two components, so which component is going to get affected because of g?
Mm,
Which
V
component of velocity is going to get affected due to this g?
the VI.
This one, v I y. That is the vertical component.
Oh, it's because VI is the angle.
Yeah, the vertical component of velocity is going to disturb due to this gravity. Whereas this horizontal component, as it is facing no such thing in this axis, so it won't be going to change. So that what we need to understand here is that Vix is the component which remains the same.
Okay.
Even at the topmost point of the journey for the projectile, the only component of velocity that the projectile possesses is Vix. That is the horizontal component of velocity it has initially. Whereas if you look at the Viy, what we find that this Viy, it keeps on decreasing, and at the maximum height or at the highest point of this journey, Viy becomes 0. Similarly, in the second half, its direction changes. Now, it started increasing its value in y-axis in downward direction.
Mhm.
So, because of the gravity, the projectile motion suffers change in its velocity, and the change takes place in such a way that there is no change in horizontal component of the velocity, but there is a huge change in the vertical component of the velocity. So, such type of motion is something we call projectile motion, and that thing came in motion in 2 dimensions or kinematics in 2 dimensions. So let us try to decode all the values, all the physical quantities that exist that are needed to be solved during the projectile motion. So here, uh, how many things we have? Let us try to figure it out. And what we exactly call those things, let us also talk about that. So suppose there are two axes, as you already know, x-axis and y-axis. So what we're going to do is we're going to look at all the physical quantities that lies under x-axis as well as under y-axis. Now let us try to understand it. So how many physical quantities we have learned so far? We have talked about velocity, acceleration, displacement, time. These are the 4 physical quantities that we have talked about. So let us try to figure it out that all those 4 physical quantities, how they exactly look like in this projectile motion thing. So the first thing, it's initial velocity. So initial velocity in x-axis as well as initial velocity in y-axis. So we just saw that initial velocity in x-axis is nothing but v cos theta or vi cos theta, whereas initial velocity in y-axis is vi sin theta. Similarly, we have acceleration in x-axis, which is supposed to be 0, whereas acceleration in y-axis, which is supposed to be negative of g. Now, displacement in x-axis. So what is the displacement the particle is going to do in x-axis, like this exactly, this distance it is going to cover in x-axis. It is something we call range. So we just mark it as range. And precisely, it is horizontal range. Because whatever motion is taking place along horizontal, the displacement is something we call horizontal range. Similarly, in y-axis, if we talk about displacement, now that's a tricky one. Let us consider the few points here. Suppose this is point A, this is point B, and this is point C. So the displacement is going to be different for A to B and for A to C. So if I talk about between A to C, like initial point to the final point for the complete journey, in the y-axis, displacement is going to be 0. How? Because you can see here, in case of y-axis, if we talk about its position, so the coordinate remains same at point A and point Y, yeah, and point C. So as the displacement, as the point remains same in comparison to from the point of view of y-axis, so we can say displacement along y-axis is going to be 0 for complete journey. Whereas if you talk about for half journey, it is going to be maximum height, which we also call h max. This is for half journey. Half journey means from A to B only I'm talking about. Because from A to B only, we can see that the particle does some displacement in y-axis like this. This is the displacement in y-axis which we call h max. This was the displacement in x-axis which we call range. So we also need to know the names of these quantities we are actually going to call them. It depends upon the journey, it depends upon which physical quantity we are talking about. Similarly, here we have another thing which we call time. So time is the physical quantity which connects both the equations. So in this case, in this type of, we can say, concept, what kind of questions can be asked? So question can be asked that suppose you have thrown an object at an angle, and the examiner will ask you, what is the position of the particle, what is the position of the projectile at t is equals to 2 seconds. You must have given initial velocity. So in that case, you are supposed to find it out using equations of motion once again, but here you have to solve equations of motion individually along x-axis as well as along y-axis, because here you have to use the equations in such a way that you solve them in x and y-axis differently, because those equations of motion are not built to solve in both the axes together. So we have to solve them differently in different axes. So let me just give you a few examples of it, so that thing will automatically make sense of how we are actually doing it. So let's do the first problem. So problem says, suppose you have thrown an object with initial velocity 25 meters per second at 30 degrees with horizontal. So the first question the co-examiner can ask, for what time projectile remains in air? For what time our projectile remains in air? So that is the first or and the very basic case. So here the examiner asks for what time. So that time is sometimes, or in the maximum cases, called time of flight. What do we mean by time of flight? Time of flight is the total time for which the projectile remains in air. So if you just look at the diagram here and we study the same projectile, assuming that initial velocity was supposed to be 25 meters per second and we have thrown it at an angle 30 degrees. So for what time the particle remains in air is something which you can find by taking out the components of this velocity along x and y axis respectively. So along x axis, it is going to be 25 cos 30. This is the velocity. So we can mark it as Vix. Similarly, in y axis, Viy, it is going to be 25 sine 30 degrees. How we can write this, because we already know how to resolve vectors in x and y axis respectively. So here Vix and Viy, we can easily find it out. Now just think about it, that which axis we should use, motion of which axis we should use in order to find out time. Like you have to think it in this way, that which axis allows me to find out time under what circumstance.
The
So let me
x-axis.
give you the, okay, let me just give you the idea about it.
Mm.
So these are the things which are given here. So if I just substitute the values, so I'll be able to figure it out that what is given in which axis. So I have given Vix, I have given Ax. I don't have displacement in x-axis. I have Sy, I have Viy given here, I have Ay given here. If I consider half the journey, I don't have displacement. But if I consider full journey, I have displacement in y-axis. Now just think of it once again, which axis allows me to use more variables instead of the other one. In y-axis, I'm supposed to have three things with me, whereas in x-axis, I'm supposed to have only two things.
Right.
Considering the full journey, complete journey, considering the complete motion. So we will use, in order to find out time, we will use y-axis. See how. Here we will use motion in y-axis. So we will use second equation of motion. And that too, I'm talking about y-axis. So for y-axis, I can say the displacement is going to be 0 because I'm considering the complete journey. Initial velocity is going to be 25 sine 30. Acceleration in y-axis is going to be negative of g. So let us take it as 10 in this case. It is going to be negative of 10 meters per second square. We have to find out time. So I'm going to use second equation of motion. Second equation says that the displacement in y-axis is equals to initial velocity in y-axis into time plus half of acceleration in y-axis into time square. So we substitute the values here. So Sy is going to be 0. Initial velocity in y-axis is going to be 25 sine 30, which is going to be, what is sine 30? 1 by 2.
1 by 2.
T plus half minus 10 t square. So here you can see that the t square, 5t square is going to be 12.5 t. So t is going to be 12.5 by 5, which is approximately 2.5. So how much time will it take? It will take 2.5 seconds, and that is the time for which the projectile remains in air.
Mhm.
So that is the case, that is the way of solving questions involving both axes simultaneously. So let us consider this as the first case. So you can say the first part of the question. In the second part, examiner can ask, what is the maximum height it will move or it will cover in y-axis? The question is find maximum height attained by the projectile. Now that's pretty simple. If I have to find out the maximum height, I have to use second equation of motion.
Mhm.
So I will say we will use second equation of motion half of the journey, or you can say for half motion.
Mhm.
So I can write Sy is equals to Uy t plus half Ay t square. Now what are the things we have here? In order to find out maximum height, we need time. So how much time that projectile has took? It is given for the complete journey is 2.5. But we have to find out maximum height. From reach, in order to reach from initial point to this midway, or you can say the maximum height point, how much time will it took? It will took half of it, because we already talked about that thing in motion under gravity section, that time for going up and time for coming down is always same. And here we have found total time.
Mhm.
So if we found total time, so the time for which the particle travels from the ground to the topmost point is going to be half of this total time. So here, that is the thing we need to understand first. Time of ascent is nothing but twice, or you can say half of total time. So I can write time of ascent as 2.5 by 2, that is 1.25 seconds. So this is the time for which the particles travel along y-axis in order to reach at the highest point. We'll simply substitute the values and we'll get height. So in place of Sy, I can write h max, that is the maximum, you can say, displacement in y-axis. Uy is supposed to be 12.5. Time is supposed to be 1.25. Plus half of Ay is always negative of 10. P is 1.25 square. So just solve the equation and tell me the value of h max here.
Mhm. mm,
So this is how we can find out
mm,
maximum height in this case. Similarly, in this question only, another thing can be asked that what is the maximum horizontal displacement this object has thus. This is the easiest one. So question can ask find maximum
mm,
horizontal displacement. So how can we do that? So maximum horizontal displacement means it is trying to ask us what is displacement in x-axis. So again, in order to find out displacement, we always use second equation of motion. Just keep that in mind. So we use second equation of motion once again, which is supposed to be written for x-axis this time. So Sx can be written as ux into time plus half of ax into time square. Now
mm,
Sx is something range, that is we have to find. Ux is what? It is supposed to be u cos theta. U is supposed to be 25, cos theta is supposed to be cos 30 degrees. Now what about time? We have to find horizontal range for complete journey, like from this point A to this final point C, I would say. So for the complete journey, we know what is the total time. It is 2.5 seconds. We already calculated it. So we'll simply substitute the value 2.5 plus half of ax. What is ax? We just discovered that there is no acceleration exists along x-axis, so it is going to be 0. Whereas if we talk about t, it is 2.5 square. In this case, range will come out as 25 root 3 by 2 times 2.5 only. So if we solve it, we'll get the value of maximum displacement in x-axis. So this is how it is supposed to be done. And again, all the three components which we have learned so far here, this is something which helps us to understand like how projectile motion actually takes place. If you look at it, the range will be 54.12 meters. It is clearly visible. Now we can clearly understood this fact that how all the physical quantities that exist in projectile motion can be calculated. Just keep this point in mind. In kinematics, we always use those equations of motion which we have learned here. There is nothing other than that we actually talk about when we talk about projectile motion. All you need to understand is how equations can be applied and how physical quantities are changing. If you understand that much thing, you'll be able to solve each and every problem of projectile motion. Although, in order to find out horizontal range, in order to find out vertical maximum height, we can use some already like derived relations, but we don't actually need those. If you understand the concept, if you know the equations, if you know how to apply them, you are good to go with it.
mm.
So always remember, something like that must be here, and that is something we call this. All right, let me give you one question. Now you can try it out and tell me. So the question is very simple. A projectile is thrown at 45 degrees with horizontal such that it covers 490 meters in horizontal direction. Question is, with what velocity projectile must be thrown? Now just think and tell me. With what velocity projectile must be thrown?
Mm,
Take 2 minutes and solve it.
Okay.
Use proper equations of motion.
Mm.
Use which axis you need to solve. Just look at what is given and which axis it is given.
So we have to use the horizontal range formula, right?
Yes.
Is it 63.4?
So how did you got it? Like how did you apply it?
So first, the formula itself is R equals U squared times sine 2 theta by G, right?
Did you got those relations? Did teacher derive those relations?
I remember that was the one you told me, right?
No. I'm asking that you're directly applying a relation of horizontal range. So
Mm.
do you know those relations?
Yeah.
What is the relation for maximum height?
Wait, what do you mean?
Just like this horizontal range, there must be a relation for maximum height. I'm asking that relation.
Um, is it H equals U squared times sine squared theta by 2G?
Yeah,
Okay.
it's that one only. But I will always suggest don't focus on remembering the relations because in the main, like you actually need it, when you actually need it, you might not be able to remember it. But if you know the
Right.
concept, you can actually solve it. So just try to figure it out that what is given in which axis. So when a
It's
projectile
not
is
one.
thrown like that
Okay.
and it is thrown with certain velocity, let me assume u. It's thrown at an angle theta. So it must have a two component u cos theta and u sin theta.
Mhm.
We have given that it covers around 490 meters in horizontal direction. So we have given range here, and to be precise, displacement in x-axis. That is 490 meters. Now, if we talk about the same, for the same case, displacement in x-axis is 490 meters. For the same case, displacement in y-axis is going to be 0. We know that. Similarly, we don't have time as well. So let us assume that the total time of the journey is t. So let us first apply this equation for Sy so that we can have time. And we can substitute the time value in x-axis, this time in Sx equation. So from y-axis, we can write Sy is equals to uy t plus half ay t square. So for the complete journey, it is going to be 0. Uy is supposed to be u sine theta. Time is something we don't know, so we just took it as t plus half of negative of g t square. So from here, we can get t as 2u sine theta by g. Now, we'll substitute the value of this time in x-axis equation. So it is supposed to be Sx is equals to uxt plus half axt square. Whereas ax is 0, Sy is supposed to be 490, it is given. Ux is supposed to be u cos theta. T is supposed to be 2u sine theta by g. Now let's substitute the values. We'll get the u. So 490 times g. So I'll take it as 10 here also. It is divided by twice of sine theta cos theta. So sine theta is going to be 1 by root 2 and cos theta is also going to be 1 by root 2 and this whole thing is equals to u square. So if you look at this will be cancelled out. So u square is something which is 4900. So u is going to be 4900. So it is approximately what? 70 meters per second. So this is how you are supposed to solve these kind of questions.
Okay, got it.
Yeah, always remember, don't try to memorize any formula. Just
Yeah,
remember the basics, that how you're supposed to use those basics to find out any unknown variable given in the question. It is not
okay.
that difficult. Although, if you want me to derive all the relations, like for time of flight, for maximum height, for horizontal range, even we talk about instantaneous velocity at any point, even we talk about equation of trajectory. Like
Yeah,
here, the trajectory is supposed to be known as parabolic in nature. So how we actually got that parabolic trajectory? What equation can we use to find out that trajectory? Everything can be find out here.